Okay, hello. Here again. I just found the video I recorded yesterday, and just now, I didn't mute, so I have to, uh, record this again. But I think this one may be the better than this one will be better than the first one because I already talk about the whole thing for once, and now it's my second time talk about this, and it's like a little bit weird if I don't have someone to interact, but it's all still okay. Also recorded some videos before, but it was in Chinese, so I didn't record a lot of videos in English. So I'm gonna talk about how to sketch the cubic function, and also I can talk about how to sketch the function with higher powers. So there are 6 steps. Then you can read it, and we will go through it. We'll go through these 6 steps in the next few minutes, and I also find the German translation for you. So let's go and see. So there's a little note about the third step, which is write in factorized form if possible. So now I'm gonna talk in advance that what is a factorized form. It's quite easy. It's just like a definition. So yeah, for the third point, what is a factorized form? I write it here for you. If you're gonna say x squared minus 3x plus 2 equals x minus 1 plus times x minus 2. So here they are actually the same thing, right? So they are the same function. So if we write this, and this is a factorized form, and this is not. So the factorized form is a form of this when you do the factorization to them. Okay, so that's quite easy. So I'm gonna just introduce what is a factorized form. Now we're going to the first point. So decide on the basic shape by considering the order and the leading coefficient. What does that mean? For example, the order of a polynomial, it's the highest power of x. For example, cubic function, has the highest power of x to 3. So the order, or let's say the degree, is just 3. For example, the highest power of x in a function is 4, then the degree is 4. And the lead coefficient, what is lead coefficient? Say for example, we have a cubic function of 2x cubed plus 3x squared plus 4x plus 5. Just random function, and the lead coefficient is just 2. The lead coefficient is the coefficient of the highest power of x. So, yeah, I already defined something. I think you may also have some similar definitions in German, but I don't know them, so I have to talk in English. So now, the cubic functions. What's the shape of cubic function? Now, we have 2 shapes. Respectively bottom left, top right, and top left, bottom right. So I'm gonna explain on why that happens. So for example, now we are going to sketch a cubic function. Now as I already defined, what is a leading coefficient and what is a highest power, right? So here, you can decide the basic shape of a function just by its degree. Let's say the order and the leading coefficient. So what's the order here? So the order here is 3 for cubic function, right? And the leading coefficient is a. So now we're gonna talk about here. Let's just see the conclusion. For a cubic function, if a positive coefficient of x cubed, let's say that means our lead coefficient a is greater than 0, right? So when a is greater than 0, the pattern is bottom left and top right. So let me explain why it's bottom left and top right. So yeah, it looked like this. So let's explain the top right first. As you can see, the top right means when x is a very big number, for example. So our x-axis look like this, and to the right means when x is a great number or a very big number. For example, x is equal to 9,999. This number is very big, and now a is greater than 0. For example, I can give you a function like this: y equals x cubed plus 2x squared plus x plus 5. And just a random function. It doesn't. I just want to show y is top right. So when x is a very big number, let's say just 9,999, we're gonna this function y equals 9,999 to the power 3 plus 2 times this guy squared plus this guy plus 5. Now you have to know something, that when x is very big, let's say x tend to infinity, that's a math way we talk about. So I'm afraid that you don't know what is like infinity, so I just give you a specific number. So when x tends to infinity, or x is very big number, x to the power 3, this term is increasing very fast. Just like give you an example about how the function of, so this is x cubed, it increases very, very fast. It's far more fast, far more fast, or my English, sorry. It's much faster, let's say just much faster than x to the power of 2 or x squared. So when x is very, very big number, so this term is going to lead the behavior of the function. So you can say the behavior of the whole function will be decided by this term instead of these terms, because these terms, as you know, x to the power 3 is increasing much faster than the other terms when x is greater, when x is a very great number or very big number. So these number are very, very small compared to this number. So that's why when x is very big, the term of x to the power 3 is going to lead the function. So then we just need to talk about the x to the power 3. So when x is very, very big number, we just need to determine the sign, or let's say whether it's a positive number or a negative number. So when a is greater than 0 and the leading coefficient is ax cubed, and here the a equals 1, but a could also be 2, 3, 4 or other numbers. So and x is a very positive, x is a positive number. You can think it as like 9,999, and think about a is a positive number, and you times a very, very big number, then you get also a very positive number, right? So this is positive, and this is very, very big. Now we get that when x is very great, so that when x tend to infinity, so y also tend to infinity, positive infinity, let's say. There are also negative infinity. So that's why when x is very big, we see the number is like the function is like a rocket driving into the sky. That's just what it means. Also, for the left part means x is a very negative number. For example, minus 9,999. And when x is a very very small number, this term is also going to lead the whole function, right? So we only need to talk about the sign of this number, and we know the behavior of function, or whether the function, the value of the function is positive or negative. So when x is a very small number, again, give you a specific number, minus 9,999, and the part becomes a times minus 9,999 to the power 3. So this one is very negative. And this one is positive. So a very negative number times a positive number, you get a negative number. So here, when x is very, very small and y is also very, very small. So we got the pattern of bottom left. Okay. So for a is greater than 0, the analysis is quite the same, and I will talk to you about it. Now we have, for example, y equals minus x to the power 3 plus 2x plus x plus 5. I don't change the remaining part, just the coefficient of the leading term. Let's say the x to the power 3. So now the pattern shall be like, when x is a very big number, so the leading coefficient, is minus this guy, and it's very, very minus. So very, very negative. So when x is a great number, a very big number, y is a very negative number. So we will have the pattern of bottom right. And when x is very negative number, then we say here a is sorry, my bad, it's less than 0. So when a is less than 0, here is minus 1, right? A equals minus 1. So here y equals minus 1 times minus 9,999 to the power 3. This is a negative number, and this is also a negative number. So their product is a positive number. So this whole thing is a positive number. And then we have this. So when x, let's say when x is a very small number, so here when x is decreasing and here the y is increasing, or x is a small number and y is a very big number. So we got these 2 points, and we can determine the shape of the function at 2 ends. Why I just say at 2 ends? So here you can see we assume that x is either a very big number or very small number. So we don't know about the middle part. We only know about when x is very big and very small. So it will only determine the shape of x when it's like extreme. It's extremely big or extremely small. So what about the middle part? So the middle part could be look like, for example, we have bottom left and top right. Here, this function, we know at the 2 ends, the function look like this. But in the middle part, the function could look like this. The function could also look like this. So we don't know. That depends on the other factors. So here, the function is only related when we want to determine the 2 ends. We only need to see this part, And now for the next few steps, now we have to think about the other parts. So that's the first step. The first step I can say is the worst step or the most difficult step to understand. When you understand this one, it's gonna be easier. Now the second step is quite easy. To set x equals 0 to find the y-intercept. And that's very obvious. For example, we just let this function. We want to find the let's just use this function. If we want to find the y-intercept of this curve, let's say we don't know the behavior of this curve, but we want to know the y-intercept, which means the intersection between the curve and the y-axis here. So we want to know this point. What's special about this point? At this point, the x value of this point is 0. So we just need to set x equals 0, and we get y equals 5. Now we can get the coordinate of this point is 0, 5. So that's what we are using here. So here we know that the point is 0.5, and this is the easiest step. And the third one is writing factorized form if possible. I already explained what is a factorized form, so I'm not going to explain anymore. And the fourth step is find the x-intercepts. So how can we find the x-intercepts? For example, we already have a factorized form like x minus 1 times x plus 2 times x minus 2. So what about this number? So about x-intercepts of a function, let's see what's special about the x-intercepts about the function. So actually these 3 points, x-intercepts means the intersection between the curve and the x-axis. So what's special about the x-intercepts? As you can see, it's on x-axis, and since these 3 points are on x-axis, that means their y value equals 0. So now you just need to set y equals 0, and you find these 3x. So this 3x is very easy to find. They're respectively x equals 1, x equals minus 2, x equals 2. These 3 points. So why is this 3 points? So if you substitute x equals 1 into it, and you see this part equals 0, so the whole function is 0. Also the same for the second one. If you substitute x equals minus 2, and you get this equals 0, and also this equals 0. When x equals 2, then this equals 0. So that's also a very easy point. Now let's go to the fifth point. Decide on how the curve meets when x-axis on how the curve meets the axis at each intercept. Let's see. Here we have for example, x minus a to the k in the factorization or in the factorized form. So why there is a k? As you can see, when I write this, there isn't a k, right? But actually there is a k. It's because these 3 brackets, they have the power of 1. So we usually ignore the power of 1. So here for this 3, the k equals 1. So why I have to write x minus a to the k is because, for example, our cubic function could also be looked like this. So in this case, you can't ignore just this 2. So you have to write this k. Okay, so our next part gonna be very easy. you just need to remember when k is odd and the curve will passes through the x-axis when x equals a. So in the function, for example, in this function, we have two intercepts. They are x equals 1 and x equals 2, right? So we know that there 1 is one of the interception, and 2 is also another interception. So here, we know that the curve passes through these 2 points, and we can determine the shape, right? Now, what are we gonna do with these numbers? For example, this term contributes to this intercept, right? And this term contributes to the intercept at x equals 1. So which term contributes to which intercept. So this term in the function contributes to the intercept at x equals a. So now you just need to determine whether k is an odd number or even number. So when k is odd, and the curve will pass through the x-axis when x equals a. And when k is even, the curve will bounce back. It look either like this or like this. Also here, when we say the curve will pass through x-axis, it's either look like this or like this. So how can we find the shape of this function? Let's say y equals x minus 1 times x minus 2 squared. X minus 1, the k here is 1. So 1 is an odd number. So at the point x equals 1, the curve will pass through like this, right? Also, we can see the next part is x minus 2 squared. So as you can see here, k equals 2. So k is an even number. So the curve will bounce back, which means the curve will look like this. So for this function, we just need to know when the curve will pass through and when the curve bounce back, and we're gonna get like the whole function. So I think the most important part is the first part and the fifth part. So the first part will determine the behavior of the function at the two ends, and the fifth part will determine the function in the middle part. Okay, so now the last step is connect all this information with a smooth curve, and you can see this step as nothing. So we already explained how to sketch a cubic function. Also, if you want to know the higher powers, there is a conclusion here, and you can read it, and how to determine the two ends. Like let's say the two ends of a function for a higher power. It's basically the same as here. So if you can decide the behavior of a cubic function, you can decide the behavior of a quartic function. Also, you can decide when the highest power of x is 5, and the highest power of x is 6, and even 100. Okay, so let's just think about some interesting questions. I have 3 examples. So each examples represent like a different curve. Okay, so for this example, now firstly we have to decide the behavior of the function at the two ends. So we just need to think about the leading coefficient. What's the leading coefficient here? So we just need to know if we write this function as y equals ax squared, ax cubed plus bx squared plus cx plus d. We just know this a, right? So what is a? We need to find what's the coefficient of x squared, x cubed. So now we know how can we get the x cubed. It's this x times this x times this 2x. So we know that the coefficient of x cubed is 2. Right, let's say the term will be 2x squared. So the leading coefficient is 2. And now we know that a is greater than 0. So when a is greater than 0, we got a top right, a bottom left shape. Okay, so you just need to know the shape in your heart. Now let's decide in the next step, we have to decide the y-interception. So what is the y-interception? We just let x equals 0. And now we get y equals 0 times minus 1 times 1. So you get y equals 0. And now you know that the y-interception could be 0, 0. Okay. Now, the next step, we have to determine the x-intercept. Right, the x-intercept here. For this term, we get x-intercept x equals 0, and this one x equals 1, and this one x equals minus a half. Okay, so now we just need to sketch the 3 points. So the minus a half is the smallest, and then 0, and then 1. Okay. Now we just sketch the axis. This is x and this is y. Now we know that the shape is top right and bottom left. So we're gonna say the shape look like this at the two ends, right? Now we have to determine the middle part. As the middle part, as you can see on here, we have 0, 0. So actually, you know, the x-intercept and the y-intercept, like they have they have the same point. They're repeated on the same point. Okay, so this is kind of special. But now we have to decide the behavior in the middle, right? So now let's just see. Let's just talk about the behavior here. So here the root is, let's say the interception is x equals minus a half. For minus a half, which term contributes to this interception? It's this term, right? And it has the k value of this one is 1. So 1 is an odd number, so we're gonna pass through. Okay. Then we decide the behavior at x equals 0. So here, this term contributes to this interception. So the value here, the k value here is also 1. So we're also going to pass through here. So the function shall look like this. Also for the last part, for the last interception, which is x equals 1, this part contributes to this one. And the k value is also 1. So we're going to pass through it. So now we get the function. Now for the next part, we have a quartic function. So a quartic function, it's a little bit different. So now the leading coefficient is x to the power, the leading term is x to the power 4. And the leading coefficient here is 1. So now, if you repeat this step, I'm not going to talk about it. If you repeat this step here, and you will get the x to the power of 4 have a top left and top right. Have a like top left and top right behavior at two ends. Then we're gonna talk about its y-interception. So we just set x equals 0, and we have 3 squared minus 3 squared times y equals minus 3 squared, just let these all be 0, and times 1 times minus 1, which equals minus 9. So we got the interception should be 0 minus 9. Okay. And we talk about its x-interceptions. X-interceptions are respectively x equals 3 here, contributed by this one, and also x equals minus 1, x equals 1, contributed by these three terms. And then we sketch these 3 points. It's minus 1, and here 1, and this 3. And now we know the behavior from these two ends. And where is the y-axis? Y-axis is here. Now we roughly have a graph. And now we know that the y-interception is 0 minus 9. So here is about like this. So we can just, this is minus 9, let's say. And now we can roughly sketch this graph. So here, this is minus 1. Okay. About this point, about this interception, you know, this term contribute to this one, and the k is 1, so we're gonna pass through it. And then about this one, we're also gonna pass through it. So let's say the function look like this. And then, what about this one? As this interception, when x equals 3, this term contributes to this one. So, as you can see, k here is an even number, which is 2. And you need to bounce back, right? So now, here you bounce back. Yeah. And we got the curve like this. Okay, for the third one, it's quite easy. It's just 2 minus x to the power 3. It's also a cubic function. So we are still doing the same. We can say, what's the leading coefficient? The leading coefficient is minus x to the power 3. And you know, here, a is less than 0. So our shape is this. Bottom, top left and bottom right. Then we have to decide its y-interception. So the y-interception is when you set x equals 0. So when x equals 0, y equals 8. So we got 0, 8. We got 0, 8. And here is x-axis and y-axis. And then what about the x-axis? There's only one interception about x-axis, which is just 2. Now we know that there's only one interception, and on this point, you know, the k equals 3. We're gonna pass through it, right? So the function shall just look like this. And this is 0, 8. Sorry for the scale, it's not very good, but you know what I mean. Because, you know, here this is a, this is 2. It's not very standard, or it's not quite on the right scale, but yeah, you know how to sketch this graph. That's the most important thing. Okay, I do have some practices. I do have a lot of practices, and if you want them, you can ask me for them after I record this video. And that's all. Bye bye.